Dear students, today we start the new chapter. So, permutations and combinations. Fundamental principle of counting. So, multiplication principle. If an operation can be performed in m different ways, following which a second operation can be performed in n different ways. Then these two operations in succession can be performed in m by n ways. This can be extended to any finite number of operations. A hall has 12 gates. In how many ways can a man enter the hall, through one gate, and come out through a different gate. Since twelve ways of entering into the hall. After entering into the hall, the man come out through a different gate. In 11 ways. So 12 gates are there. So he can enter in 12 possible ways, but he has to come out in different gate. So there are only 11 possibilities. Total number of ways. One 32 ways. Another example. There are 3 stations A, B and C. Five routes for going from station A to station B. And 4 routes for going from station B to station C. Find the different ways through which a person can go from A to C via B. There are 3 stations A, B and C. 5 routes for going from station A to station B and 4 routes for going from station B to C. Find the different number of ways through which a person can go from A to C via B. From A to B, 5 routes. A, B, C. 5 routes are there. From B to C, only 4 routes. First he has to reach B, then to C. Total number of different ways 5 into 4 20. Addition principle. If an operation can be performed in M base, and another operation which is independent of the first operation can be performed in n different ways. Then either of these two operations can be performed in m plus n ways, either a, m or either first operation or second operations. Therefore, m plus n ways. This can be extended to any finite number of operations. For AND we have to multiply, for OR we have to add. First operation and second operation, that means you have to multiply the number of ways. First operation or second operation, we have to add. There are 25 students in a class. In which 15 boys and 10 girls. The class teacher either a boy or a girl for monitor of the class. And how many ways can the teacher So totally have 25 students, 15 boys and 15 girls. There are 15 ways to select a boy and 10 ways to select a girl. The total number of ways, either a boy or a girl, or means you have to add 15 boys, or that means you have to plus 10 girls. 25 ways. factorial notation. The continuous product of first n natural numbers is called factorial n. To be denoted by n factorial. Or this notation you are going to use. For negative number, the factor is not defined. So n factorial means n into n minus 1 into n minus 2 up to 4, 3, 2, 1. Continuous product of first n natural numbers. If we combine first n minus 1 terms, so n into, we can write up to n factorial. 1 to n minus 1 we can take n minus 1 factorial. So n factorial equal to n into n minus 1 factorial, like that. If we take this alone, n factorial equal to n into n minus 1 into, that is n minus 2 factorial. So n factorial equal to n into n minus 1 factorial, n factorial equal to n into n minus 1 to n minus 2 factorial, like that. N factorial equal to n into n minus 2. The next continuous n minus 3 numbers, n minus 3 factorial, n into n minus 1 into n minus 2 into n minus 3 into n minus factorial. For example, 100 factorial means 100 into 99 into 98 into 97 up to 321. This can be written as 100 into 1 to 99, 99 factorial. If we take 100 outside, you have 99 factorial. That can be written as 100 into 99 into 98 factorial. 100 into 99 into 98 into 97 factorial. Like that we can write. Factorial 0 equal to 1. Two n factorial, that means 2n minus 1, 2n minus 2, 2n minus 3, 2n minus 4, 4, 3, 2, 1. You collect all the even terms. 2n, there are 2n terms. 2n minus 2, 2n is 4, 4, 2. Then you combine odd terms, 2n minus 1, 2n minus 3, 2n minus 5, 5, 3, 1. So totally we have 2n terms. Here n terms, here n terms. These are even numbers. You can take 2 in common. So you can take 2 n times. That is 2 power n into n. If you take 2 in common, n minus 1. Here n minus 2. Last 2, 1. 2n minus 1. 2n minus 3 up to 5, 3, 1. That is 2 power n into n factorial into, so 2n factorial is coming as 2 power n into n factorial into 2n minus 1, 2n minus 3 up to 5, 3, 1. So very important results that is useful to find values. So factorial addition can be used not only in permutation combination, in some other chapters also we will use it. N factorial by R factorial. N minus 1, n minus 2, etc. N minus n minus r plus 1, n minus r, n minus n minus r minus 1, n minus r, n minus 2, etc. R plus 1 into R minus 1, etc. 3, 2, 1 divided by R factorial, R into R minus 1, R minus 2, etc. 3, 2, 1. So up to this can be cancelled. So n into n minus 1 into n minus 2, etc. It is enough to write up to, if we divide R factorial up to R factorial cancelled, remaining term R plus 1 to n only will be there. This is possible when R is less than n. N by n minus r factorial. N into n minus 1, n minus 2, n minus 3, etc. n minus r plus 1 into n minus r, n minus r minus 1, etc. 3 to 1 whole divided by n minus r, n minus r minus 1, etc. 3 to 1. So this term will be cancelled. N into n minus 1, n minus etc. n minus r plus 1. So n factorial by n minus r factorial means n minus r up to n minus r plus 1. Here r is less than n. One by n factorial plus 1 by n plus 1 factorial equal to lambda by n plus 2 factorial. 1 by n factorial 1 by n plus 1 factorial equal to lambda n plus 2 factorial implies lambda equal to n plus whole square. You see n plus 1 n plus continuous numbers, factorial numbers. Lambda should be equal to n plus whole square. You can remember as the results. For example, 1 by n factorial plus 1 by n plus 1 factorial equal to lambda by n plus 2 factorial. So 1 by n factorial plus 1 by n plus 1 into n factorial means lambda by n plus 2 into n plus 1 into n factorial. So among these three numbers, n factorial is the lowest value. We convert all the values in terms of lowest value. Then here you can take n plus 1 into n factorial LCM. Here we have n plus 1 plus 1 equal to lambda by n plus 2 into n plus 1 into n factorial. The n factorial will be cancelled. N plus 1 will be cancelled. Here we have n plus 2 divided by lambda by n plus 2, which implies lambda equal to n plus 2 whole square. So you can remember as a results. Whenever the continuous numbers are possible, you can write. For example, 1 by 100 factorial plus 1 by 101 factorial lambda by 102 factorial, which implies lambda equal to 102 the whole square. Without simplifying, you can write straight away. If x factorial equal to y factorial, which implies x equal to y, or x equal to 0, y equal to 1, or x equal to 1, y equal to 0. x1 must be equal or x0 y1 or x1 y0. evaluate summation r equal to 1 to n into r factorial. R into r factorial. R equal to 1 to n so r plus 1 minus 1, r can be written as r plus 1 minus 1 r factorial. That is equal to r equal to 1 to n r factorial into r plus 1 minus r factorial. R equal to 1 to n r factorial to r plus 1, that is four factorial into 5 means 5 factorial, like that. R factorial next value, very next value, r plus 1, that is r plus 1 factorial minus r factorial. If we take r equal to 1, 2 factorial minus 1 factorial plus 3 factorial minus 2 factorial plus, if we take 3, 4 factorial minus 3 factorial plus etc. If we take n minus 1, n factorial minus n minus a factorial, when we take n plus 1 factorial minus n factorial, 2 factorial, 3 factorial, 3 factorial, like that, all values will be cancelled. This will not be cancelled. N plus 1 factorial minus 1. Find the remainder when r equal to 1 to n, r factorial is divided by 15 if n is greater than or equal to 5. Let n equal to sum of r factorial r equal to 1 to n. One factorial plus 2 factorial plus 3 factorial plus 4 factorial plus 5 factorial plus 5 factorial plus 6 factorial plus 7 factorials up to n factorial. 5 factorial means 120, that is divisible by 15. 5 factorial means 5 into 4 into 3 into 2 into 1, that is 120, which is divisible by 15. So we can take 5 factorial common in all other terms. Therefore This will be divisible by 15. This is equal to so n equal to 1 plus 2 plus 6 plus 24 plus 5 factorial plus 6 factorial plus etc. n factorial. 3 factorial means 3 into 2 into 1 6. 4 factorial means 4 into 3 into 2 into 1 24. 4 into 3 into 2 into 1, that is 24. So n equal to 33 plus 5 factorial plus 6 factorial up to n factorial. Thirty-three 15 plus 5 factorial plus by 15. Here 2 into 15 by 15 will be cancelled. 2 plus 3 by 15 plus 5 factorial 6 factorial up to n factorial divided by 15. Two plus 3 by 15 plus this is some integer. It is whole time is decimal 15. Some integer. The question will be some integer. Integer plus 2. Again an integer. 3 by 15 plus integer. Therefore, we want to find the remainder. So 3 is the remainder in this case. Exponent of prime p in n factorial. It's very important concept. Exponent of prime p in n factorial is denoted by E p of n factorial, exponent p of n factorial. Where p is prime number and n is natural number. The last integer amongst 1, 2, 3 up to n minus 1 comma n okay, it's not necessary. So EP means exponent of p in n factorial. So EP n factorial equal to n by p is a greatest integer function plus n by p squared n by p cubed plus etc. n by p power s. Where s is the largest natural number such that p power s less than equal to n less than equal to p power n plus 1. So n lies between p power s and p power s plus 1. So this denotes greatest integer function. Denotes the greatest integer function. The number of zeros at the end of n factorial equal to exponent of 5 in n factorial. Find the exponent of 3 in 100 factorial. Exponent of 3 in 100 factorial equal to 100 by 3, 100 by 3 squared, 100 by 3 cubed, 100 by 3 power 4, 100 by 3 power 5 plus etc. But 33 into 3, 99. So here would be integer part 33. 100 by 9, 11 times 11 into 9, 99. So here 11. Here 100 by 27, 3 times, 3 point something. Since it's the integer part, you have to take integer only 3. 3 per 4 minus 81. 100 by 8 to the leave 1 time. This value exceeds 100. So we have to, if we take this, we have only 0. 100 by 243, 0 point something. The integer part is 0. So remaining all terms will have integer part like that. So 48. So exponent of 3 in 100 factorial is 48. Find the number of zeros at the end of 100 factorial. Number of zeros at the end of n factorial equal to e phi of exponent of phi in n factorial. So exponent of phi in 100 factorial equal to 100 by phi, 100 by phi squared, 100 by phi cubed plus etc. Here 24 times, 20 times here, 100 by 25, 4 times. We have only 24. What is the largest integer n such that 33 factorial is divisible by 2 power n. So e to 33 factorial equal to 33 by 2, 33 by 2 squared, 33 by 2 cubed, 33 by 2 power 4, 33 by 2 power 5, 33 by 2 power 6 plus etc. So 2 power 5, 32. Here 16 times, here 4 times, sorry 8 times, here 4 times, 2 times, 1 time, remainder will be 0. So exponent of 2 in 33 factorial equal to 31. Hence, largest value of n is equal to 31. So, we will discuss more in the next session. Thank you.